showing up here tonight. We made it all the way from Kiev over to Bucharest. We've really enjoyed being in Romania. It's actually my first time in Romania, and specifically Bucharest. And so I'm very excited to be here. And I'm always very excited to spend time with any Java community. I was the president of Java user group out of Atlanta for many, many years. I also founded my own conference, like Alex is doing here, called DevNexus out of the Atlanta, Georgia market. And so that conference is now up to 2,000 people or so attending. And the Java user group continues to be a robust organization. And so I really love community gatherings in general. Also been a Java champion because of all my work with the community. I'm also part of Red Hat in my day job. I was actually part of the JBoss organization when we were acquired by Red Hat. So I've technically been at Red Hat for 10 years now. If you guys would like to reach out to me, feel free to reach out to me on Twitter at Burr Sutter. And you can also email me. The slides for this presentation are at that bottom URL there where it says Java Doc Cube. So bit.ly Java Doc Cube. Here, I'll zoom in on it so you can see it. I recognize for people watching online, you can't see it there. But in the room, you can see bit.ly Java Doc Cube. And also the primary demo you'll see, if everything works for me, is at that URL if you want to learn how to run this demo for yourself. So the reason this is important is I want you to be empowered to go deliver this same presentation inside your organizations, inside other communities within the region. And you can take the slides, it's full source to the slides. We're an open source company, full source to the demonstrations. You can do this running on your laptop also. Okay, so let's go ahead and dive right in. One thing I want to make sure that we cover quickly is the concept of microprofile. So you guys are probably in the Java EE space. A lot of people do enterprise Java. You might do Spring in addition to enterprise Java, but you probably use some servlets or JAX-RS or JPA. You might also use some Hibernate in addition to Spring. You might even still use Struts, Struts 1 in most cases, not Struts 2. Very few people actually use Struts 2. But there, depending on what background you come from, you might even still do Swing programming, right? Client-server Swing programming. And so we see that within the Java community. And one of the things that we wanted to do specifically was get Java 8 or Java EE and Java EE8 started down the microservices path. This presentation primarily focuses on microservices. The demonstration, if I have it running properly, when I turn on the laptop here, we'll show you Spring Boot, Vertex, Wildfly Swarm, Drop Wizard. We have a Drop Wizard microservice. We have a Node.js microservice. We'll show those all integrating with each other, or at least show several of them. And so we're very focused on this new space of taking advantage of things like Java in a microservices context, specifically with Docker containers. And we'll do everything with Docker containers and Kubernetes, and we'll discuss all three of these things as we go through this presentation. When do I need to get off the stage and let Edson on exactly? 45 minutes? Okay, which means I'll have to go fast. But by default, go to microprofile.io, and you'll see there that's where our website is, working with other organizations like IBM, working with Payara, working with Tommy Tribe. Also, we're supported by the London Java User Group, as well as the Brazilian Java User Group, and Hammock as an organization. And so we are all working together to find a new specification. And then that'll be contributed back to the JCP, the Java community process. So we're working within the community to define new community specifications. Primarily what we're doing is working within Java EE and finding new ways to use those same APIs, like JAX-RS, like CDI, like JSONP, and others. Okay, this is the symbol we made for Java 1. It's a Duke made of micro Dukes. Kind of cool. But go to microprofile.io and you'll see more about this concept. All right, so let's dive right in. So Red Hat, if you've not heard of Red Hat before, is the world's largest open source organization. By world's largest, I mean we're about $2 billion in revenue at this point. It's gotten very big. We're over 9,000 people, I believe. So we're doing pretty well as an open source organization. And I've been, like I said, there 10 years when I came with the JBoss acquisition over a decade ago. I've been doing Java, though, for about 19 years. Ed and I were comparing notes right before this, like, yeah, 19, 20 years, for each of us doing Java as an example. But Red Hat does a lot of sponsorship of a lot of really cool projects. So we'll show you a few of these tonight, but there's a ton more we could talk about. We could spend days here talking about open source projects. And so one thing I'd encourage you guys to think about is what is your participation in open source? Open source works because we all contribute, and a contribution may not only be a piece of code. Most people think code, but it's actually not only code. If you find the bugs and log the bugs, that's a huge win. if you write the documentation, if you write the tweets and blogs, if you go out and present at your local user group, or even just for a lunch and learn at your company, that's a huge win for that open source project. So every contribution matters in this space, and this is why open source is working for the world at large. I see this gentleman has a Tommy Tribe shirt on. Do you work for Tommy Tribe? No, but you might want to one day. Okay? And so wearing the t-shirt and proudly promoting Tommy Tribe, that's a contribution, a small one, but still a contribution. But if you contribute to the upstream open source project, Tommy Tribe works just like Red Hat does. Because there's a friend of Edson's down in Brazil who just got the job at Tommy Tribe. So they look for his contributions, they see his contributions into the GitHub repo, and they go, we can hire someone, we have budget. That person is the one that gets hired. And they hire you wherever you are on the planet, and they put you to work. And then you're working with a paycheck for an open source project. That's actually pretty awesome, okay? So there's a lot of things you can do in space. I don't want to belabor that point because we got to keep moving. There's a free book. This is no longer what the website looks like, but if you go to developers.redhat.com, there's a free book that we're offering out there for Spring Boot, Drop Wizard, and Wildfly Swarm. If you want to learn how to build microservices on the JVM, it'll take you through those 3 patterns. It'll also walk you through a little bit of Docker and Kubernetes and some other aspects like history, circuit breakers, some of which you'll see in this presentation as we get going. Okay? Microservices are fundamentally about one key word, agility. There are things your organizations will not like. The companies you work for, the big boss at the company, if you are the boss, you're going to go, we're not doing that here. Now, here's the weird part. When we get into this, you'll see what I mean. The weird part is you're probably thinking, I have to do microservices. I'm a programmer in Java. All Java programmers have to do microservices. I know, how many people actually already have that thought in their head that you've got to do microservices? Okay, you should raise your hand. It's weird. I do this presentation around the globe. In India, in Vietnam, and Asia, right? In North America, South America, Europe, and most people think, I got to do microservices. We're going to talk to you a little bit about why you do and why you don't, but we do realize right now it is kind of a movement. People have to do it, okay? And so the trump card is agility. If it gives you greater agility, you say yes to it. If it does not help you gain greater agility, you say no to it. And there's actually a very famous study. This one released out there, so in one of my other presentations, where a fellow who's been documenting and describing A/B testing for the last decade or so, used to work for Amazon, now works for Microsoft. His name's Kavi, it's Khabi. 1/3 of the features you build add positive value for your users. 1/3. 1/3 add no value, 1/3 add negative value. So 1/3 of what you do will hurt your users and your company. 1/3 of what you do will do nothing. And 1/3 of what you do will do the right thing. So think about that for a second. If we could all put our other 2/3 to work, can you imagine how much more productive we would be? And we could change the world with that other 2/3. So just keep that kind of stuff in mind as you think about that, because it really helps you decide how you might embrace these new ideas. I'll just put that out there. It's at the peak of inflated expectations if you follow the Gartner hype cycle. In other words, everybody's talking about it. Not everyone's doing it, but everyone's talking about it. It does have to go through the trough of disillusionment, which means, God, this sucks. And then it comes out the other end where everybody's just using it and not talking about it. This matters a lot in our industry. Gartner's studied this for 2 decades plus. It matters so much because this is what we do with everything. Remember big data? We used to talk about big data all the time. It was going to cure cancer, feed the hungry, clothe the naked. You remember that? Now we don't talk about it as much. We just do it. Okay, so it had to go through its cycle, and microservices has to go through its cycle. Let's keep going here. So your journey to microservices includes you need to have some form of self-service, on-demand, elastic infrastructure. Depending on what size organization you work in, if you're a developer and you need a production-like environment to test your code, because you would like to test your code before it goes to production, right? And you'd like to test it on a production-like environment. If you deployed a Solaris, you'd like some Solaris. If you deployed a Linux, you'd like some Linux. If you deployed a Windows, you'd like some Windows. For most organizations, it takes 3 weeks for that developer to get that virtual machine provisioned. Now, for some of you are thinking, 3 weeks? That's fast. Okay, for a new piece of new hardware, a new virtual machine. For others, you're like, 3 weeks? That's ridiculous. It only takes my organization 3 seconds. You want to be more in the 3-second range, not the 3-week range, because it should be an API-driven infrastructure as code. You make the request, it spins up the resource based on your quotas, you take advantage of the resource, and then dispose of it when you're done, okay? Self-service on-demand elastic infrastructure is absolutely critical as you move forward and you try to get that additional agility, right? Agility is the key. This gives you greater agility, by far greater agility than waiting 3 weeks for a virtual machine. Reorg to DevOps, okay? This is where, as a developer, not an operator, you don't chunk your crap over the wall to the operator on Friday night, and you go home, and they spend the weekend trying to make your junk run, okay? You work together. If it's your stuff, you stay there all night too. You stay there all weekend also. You ensure that you're one-on-one with that operator, and guess what? I can guarantee you one thing. If you do that, you'll write better code. I saw this personally with a team I managed prior to joining JBoss. We specifically had to put a production rollout immediately. We just had, it was not tested. We hardly even finished the code, barely compiled. But, business had to have it deployed. And if you've not read the Phoenix project, by the way, you should, because it's exactly that. We had to deploy it, and then we had to immediately roll it out. And, operators like, it doesn't run, it doesn't run. Once I decided, since I was a manager, all developers, you stay all night too. It only took about 3 weeks for the code to get really good, because people didn't want to be there all night and they didn't want to be there all weekend. We had bug fix Saturdays. 2 bug fix Saturdays were required before. There weren't any more bugs on Saturdays. They were all fixed by Friday. It's like a miracle, okay? But it's about accountability, and it's about ensuring that your organization is tied together in such a way where everybody's successful. We want to succeed together. That's critical. You want to think in terms of automation. If you're still feeding CDs into a CD tray, like we used to at MSDN, when MSDN would send us a stack of CDs? Some of you are too young for this, I know. You're thinking, what's a CD? They're these silver discs, and we had to feed them to the machine like cookies to a Cookie Monster. You guys probably don't know what I'm talking about. Okay, but we had to do this. But now you do everything through a script of some sort, specifically like Puppet, Chef, or Ansible. Ansible? That's interesting. I got some. Okay, but then you use that automation to basically provision your infrastructure and provision your tools. And also you want to look at things like containers. You want to think about CI/CD. You want to think about your deployment pipeline. You want to be really doing continuous integration. And there's 2 rules to continuous integration. One is trunk is always deployable to production. You're probably thinking, what? That's kind of crazy. Trunk is always deployable to production. Number 2, everyone checks in the trunk every day. Everyone, every day. At least once, okay? That's the longest interval. Ideally, everyone checks in all the time, and it's always deployable. That's when you're doing continuous integration. That's specifically what Jez Humble, the guy who wrote the book, says that's his test. So if you see any of his presentations, he'll ask you to take the test live in front of the audience. And what will happen is everyone goes, oh, I'm using Jenkins. And then he'll say, how many people check, whose trunk is always deployable? Most of the hands go down. How many people check in every day? The rest of the hands go down. Then he'll say, you're not doing continuous integration. You're just using Jenkins. Okay, there's a big distinction. All right, once you do all these cool things, you're going to be like a superhero and you're ready to build a microservice like this monkey. Okay, and then you too can be a Silicon Valley unicorn. All right, well, we got to move along here. Martin Fowler also talks about these same things in a blog post he wrote from multiple years ago at this point. You must be this tall to do microservices. I don't know if this translates here in Romania, but specifically, I was the short person. So when I went to the amusement park or the fair, the carnival fairs, whatever, I couldn't get on the ride. I was too short. Saying, let me on the ride. So in his case, he says, you got to be this tall to ride this ride. That's the idea. All right, so let's keep moving. In the case of a monolithic architecture, you have so many weeks to deploy that monolithic architecture. That big old application has to get deployed with a big old team of individuals who all have to agree that it's time to roll that to production. That's what happens, right? Everybody, all 20 of us, or all 50 of us, all 100 in this room, or whatever there may be, we all agree we're on this big monolithic project. It's time to deploy, okay? And I just said 24 weeks here because 24 weeks nicely translates into 8 3-week sprints. And we tend to do 3-week sprints. So we do all these agile sprints, and then we do this big bang deployment at the end. That's fundamentally broken. That's where, if you can't fix that problem, You don't really want to do the microservices thing because you're just going to suffer some pain, okay? So what you got to start thinking in terms is, how good is our automated testing? How good is it? Is it brilliant? Or is it, 20% of it works kind of part of the time? Here's a better test for you. This is another Jez Humble thing. Here's a better test. If the build breaks, how long does it take you to fix the build? Okay? The basic rule of thumb from Jez is it's all hands on deck, no longer than 10 minutes. A build is never broken longer than 9 minutes and 59 seconds. That's what they're doing to fix that build. That's how important it is. So if you get really great at continuous integration and build automation, and you really think about automation in general, you're going to basically make that happen. You might go faster as you start taking advantage of things like Docker, start thinking of things orchestration in terms of like Kubernetes, infrastructure as code, continuous delivery pipeline will help you go faster. If you really get into zero downtime deployment strategies, and I'll try to demo a blue-green deployment and a canary deployment for you. I have a cloud running on that laptop, on this laptop. You'll be able to go even faster. Now here's where it gets tricky. How do you go below 3 weeks if you do 3-week sprints? So this is the magic question. This is what gets your mind around the whole microservices strategy. How do you go faster than 3 weeks? You basically have to break up that monolith, okay, so that it's multiple projects. Then every project deploys at their own intervals. That's when you're in the microservices land. Now here's one thing that's very important. I speak to a lot of audiences about these topics, and we've seen real large banks, as one example, a banking organization. They've employed all the other techniques up front, and they got a 3-month project down to a 3-week deployment cycle. They even got even better, down to a 1-week deployment cycle. And they're zooming along. They're deploying every week, okay? That's as fast as they need to go. That might be as fast as you need to go. Can you imagine that? 1-week deployment cycles? That would be amazing for some of your organizations. Here's why it's even more amazing. You, as the person who created the software or contributed to the creation of the software, where you be the project manager, business analyst, whatever you might be in your role, QA person, ops person, you need the feedback of your real production environment. You need the feedback of those end users to know if you did it right or not, to know if you did the 1/3 of good versus 1/3 of bad, or the 1/3 of nothing. You got to know, did I do the 1/3 of good this time? Because if I didn't, I need to go back and look at what I did and maybe fix it and try to get back in that 1/3 of good. Does it make sense? Okay? All right. How about 10 deploys per day, as it says in the Phoenix project? John Amspaul of specifically Etsy declared this, and they talk about it in the Phoenix project. If you've not read this book, I highly recommend it. I've read it twice. I actually recommend reading it every 3 to 6 months. I'm serious. Because you'll forget it, and then let me read it again. And then I personally have gone through my own Phoenix project, right, where we literally destroyed the business with a bad deployment, a bad piece of software. And $5 million in business we shut down. So read this book, understand the journey that these folks are on. It's a fiction book. It's written like a story. So it's fun to read. At the same time, it makes you think, how often is my software contributing to the good as opposed to contributing to the bad? Okay? So we'll keep going. In order to keep going fast, you got to break up that monolith into separate individual projects. You got to break it up into microservices. And each of these little individual teams with their individual projects can now go as fast as they need to go to meet their business needs. That's the key driver. Are they meeting the business objectives? Are they making their business more competitive? Are they making their business more agile? Are they meeting the customer needs faster? Most importantly, are you learning faster than everyone else? Because if you're learning faster, capturing feedback faster, introducing that feedback into the software development cycle so you can produce even better software, and you're taking advantage of things like canary deployments and then A/B testing, then you will outpace the competition. As a matter of fact, by the time the competition realizes what you're doing, you will be at a pace and a velocity that blows right by them before they even figure out that you're doing something different than they are. This is why organizations who employ these techniques are vastly more competitive than others. Okay? Key microservices principles. We don't have time to belabor all these. I want to show you the demos because the demos are much cooler. But the deployment independence is by far and away number one. Deployment independence. I should be able to deploy my project, my piece of software, my microservice by itself, whenever, wherever, however I need to, with zero negative impact on the rest of the system. As a matter of fact, no one else in the world, right, inside this microservice architecture should even know I redeployed my service. They don't even know. If you can get that far with it, if you can be that agile with it, then you've done something that's magical. And I'll try to show you some examples of this as we go, okay? There's a lot more that you want to focus on here, like organize around business capabilities, optimize for replacement, be API focused. All these things are important. The two that break the bank for most big enterprises, especially like a bank, break the bank, get it? I guess I shouldn't use American euphemisms, right? But literally in the case of a bank, decentralized governance, meaning all these individual teams govern themselves. They choose the right strategies and tools to best meet their business needs. They produce a product, not a project. They're tied to that product for their entire career at that company. In some companies, you work from project to project to project to project, right? As developers. You code here for 2 months, you jump over here and code here for 3 months, jump over there and code for 4 months, come back over here and code for another month. That's wrong. Because now you have to context switch. You have to relearn. Okay, this one is using Spring version 3 and Hibernate version 3. This one's using Struts 1. Oh God, right? This one's this one's actually modernized, right? It's using JSF. Oh no, right? I want to go back to Spring. But it doesn't really matter what it is. The context switching will kill you. And more importantly, you're not getting the feedback cycle when that goes to production. You need to run it all the way through production. And when it breaks in production, you stay up all night and all weekend until it's right. And you take that feedback and go make better code. You live with it. That's why they call it product, not project. You're a product owner, not a project contributor. Does that make sense? We're talking too fast yet? Okay, good. Lots of things in a microservices world that you would need to think about, like load balancing, scaling, elasticity. We'll show you those things from a Kubernetes standpoint. Also think about your service discovery. So in other words, how does service A find B, find C, so they can invoke each other? A calls B, B calls C as an example. You want to think through resilience architecture. You need to design for failure. Not because you want failure, but you acknowledge failure will happen, especially in distributed architecture like microservices. It's guaranteed to happen. That server will just die. Its memory chips will get corrupted. Its hard drive will just go bad, right? The power supply will just eat itself. I've seen this in servers. I don't know if you guys have. It'll just go bad. Or as a matter of fact, even if it's a VM, not even a real server, the VM just gets flaky and just drops packets. It just stops responding. So things break. You have to design for that failure. You have to have highly resilient software. We'll show you an example of that in the demo also, okay? API focused, think about your invocation model. Lots to say about that. We don't have time for a lot of that. Think about your distributed tracing, your deployment model, your distributed authentication model, distributed logging, distributed monitoring, and logging. These are all things you should be thinking about as you enter the microservice world. Now, I say all these things, not because we can answer them all in this one short presentation, but you should be aware of them and thinking about them when the boss comes to you and says, hey, aren't we doing some microservices here? Because it's going to happen, okay? And if the boss doesn't say it, the business will say it. Aren't we doing some DevOps and microservices? Yeah, okay? But you need to be thinking about all these attributes, okay? Some key technologies in the space, Spring Boot, all right? So Spring Boot is the one many people know. Dropwizard did this first, though. Let's kind of all acknowledge Dropwizard did it first. They gave you the concept of putting a JAX-RS endpoint plus Dropwizard metrics. They give you an embeddable Jetty server. You roll it all up to a fat jar, right? It's a single executable jar. You do java-jar, the jar name, and it runs anywhere there's a JVM. It's like magic. No application server to install, right? You don't load an app server and then take your app to the app server. You take the server with the app. Completely different than what we used to think. But Dropwizard kind of came out with that first. Spring Boot, of course, is one that's very popular now. And there's also one from the Wildfly guys, Red Hat people, that's doing Wildfly Swarm. And then now that we have MicroProfile, you're going to see it coming out of Payara and Tommy Tribe also. So a lot of players in this space, a lot of opportunities. Another one I would encourage you to check out is called Vertex. That's probably my most favorite project. And it's an asynchronous real-time API. And I could show you a ton of cool stuff around Vertex, but we don't have time. But literally, if you want to do a highly dynamic application where literally as the user is typing over here, the other user sees what they're typing. If you've used Google Docs or Etherpad, you'll know what I'm talking about. Vertex can help you build that kind of application. So it's a really neat little technology, and it's super tiny. And again, it's embeddable, fat jar, maybe a 20 meg jar, and that's what you deploy as an example. You need to learn something about a circuit breaker. Circuit breaker is when service A calls service B. This was first documented in a book called Release It. So I'd highly encourage you to read Release It as well. But service A, when it calls B, what happens if service B fails? Or here's the more insidious thing. So if you don't remember that part of it, the more insidious thing is, what if service B is slow? It's connected. It's even kind of responding, just incredibly slowly. That'll destroy your entire system's infrastructure. It's better to be down than slow. Slow will kill you, okay? So the circuit breaker in the case of Hystrix OSS helps deal with that. It certainly prevents it from you dying if it's dead, right? It'll help you deal with the fact that that other guy's dead. Don't kick him any longer, all right? That's one big key feature there. Think about that for a second, though. If you are a developer and you've built a web application before, and it's a browser-based application, what happens when your stuff goes down or it's slow? What does the user do for you? They hit the refresh button again and again and again. And so literally your service is on the, on the floor dying. You're like, kick it again, kick it again. That's the idea of the circuit breaker, is it ensures that you stop beating up the guy who's dying, okay? If service B is struggling, because think about it, if it's struggling to come back up and have enough resource and work, right, and you're literally rebooting the server, and all these requests are trying to jam in where you're literally booting the server up, you could just be dead and dead and dead and stay dead, because it just will never come back to life, right? In the case of a circuit breaker, it would go boom, 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 hit it, not responding, and more importantly, not responding fast. Okay, let it be. And basically what happens on this side of the circuit breaker, all the other requests bounce off. We'll show you that in demonstration to make it more sense, right? So literally you bounce off, and every now and then one goes through to see if it makes it through. And if it does, we're good. If it doesn't, you let them bounce off again. And it just periodically checks. Did that one go through? Nope, bounce off. And it's better to bounce off than all be dead, right? Because your service can now respond with, oh, I couldn't invoke that other component, so I'll take some default logic associated with that component and display that to my user. Okay, let's keep going. There's also concept of distributed tracing in our demo. You'll see that through Zipkin. We want to show you that. All this runs in something we call the CDK, Container Development Kit. It's essentially a virtual machine running on your laptop. It's a whole cloud running on the laptop. I think I'm probably running probably about 20 different JVMs right now within that virtual machine. I've run up to about 30. So you can run a lot of JVMs if you do it right. All within little Docker containers, all running in a nicely scalable way underneath Kubernetes. And that's what this Kubernetes architecture is all about. So let's talk to you quickly about Docker. So for a Java developer, you might have been burned with this before. For most Java developers, they develop on Windows, not Windows 95 anymore, right? We've moved up, okay? But still Windows. Anybody here still on Vista? It's okay if you are, right? Okay, I was on Vista a long time. But you develop on Windows and you deploy to Linux. And guess one of the things that bite you? This little backslash versus forward slash. Anyone been bitten by that before? Yeah. Just the simplest example in the world where the slashes are going different directions. And all they try to do is open the damn file, right? So one good example, so what about the data source name? Slightly differently misspelled name. Someone misspelled the data source name, right? Someone didn't give me the right JDBC version. We don't agree on what the JDBC version is. So what about a patch to the JVM? Has that burned anybody before? A different version of the JVM? It's still 1.6 point something, but the point something matters. I've had that burn me once too, and it takes you like days to debug this. You're like, no, it works on my machine. Get that phrase? It doesn't work in production, and that's all that matters. So if your stack really matters, your application sits on top of all this configuration. It sits on top of a JDBC driver, a data source, perhaps JMS message queues or topics. User IDs and passwords have to be configured for that infrastructure. Your application server, you got to know what version of it is, what patch version of it is, if it's WebLogic or WebSphere or JBoss, right? My application server. If it's Tomcat, it doesn't matter what it is, you got to know what version and what patch level it's been versioned at, and its configuration. You got to know what version and patch level of the JVM. You certainly need to know the version and patch level of the operating system, otherwise the slashes will get you. And all that sits on top of a piece of hardware or a virtual machine. The entire stack matters. And when you make a mistake, it all goes to hell, right? And so if you want to go fast to production, you got to fix this stack problem. All right, so here's an example where the developer throws it over the wall to the operator, and the operator gets this package, their war file, your ear file, and they're like, what the hell do I do with this? As a matter of fact, you then say, well, I've been testing my war file on my Windows 7 desktop, not Windows 95, but Windows 7. I have this version of the JDK because I want to be on Java 1.8. I'm cool like that. I got the latest version of Tomcat. I got my data source configured to MySQL because I love MySQL on my desktop. But production has Red Hat Enterprise Linux 6.2, Java 1.7, WebSphere 0.8, right? Or WebSphere 8.5, and an Oracle database. That's what production looks like. Now you're screwed again, right? You're like, okay, my development world does not look like my operational world, my production world. And so what you do is you get this thing called a Docker file and use the Docker file to sort this out. Because in the old world, you know how you would communicate this? You would send an email to the QA person. My war file requires, you type it all in, hit send. Oh, I forgot to say something. Let me send another email. Oh, but this version of the patch version of the JVM, send the email. So now the QA person's got 3 emails that say slightly different things. Okay, and then they forward it to the operations person for deployment, and they misinterpret what you meant in those 3 emails. It just happens. It's human nature. I read things differently than you read things. Okay, you said JDK 1.8. I thought I could just use a JVM, JRE, right? But you needed a JDK. I didn't know. Okay, JRE should have been fine. Little things like that. So that's part of it. The other part of it is for some of you who are very clever, you're like, we don't send emails. We do a wiki page. Guess what? The wiki page is still wrong. And in this world, it's all codified in a single executable file that ensures we all agree to the stack. That's what I love about the Docker file. We agree. As a matter of fact, the entire environment runs on my local machine, and you can run this exact same thing in production if you choose to. And therefore, the whole image rolls through the continuous deployment pipeline. It goes from my desktop to the CI server, gets all checked out there. It goes from the CI server to the QA server. If you have a QA server, it gets checked out there. It goes to the staging server or the load testing or soak testing servers. It doesn't matter how many servers you have, and eventually it shows up in production as the exact same thing. That's why this thing is so magical. All right, let's talk about Kubernetes. Kubernetes is a project we work with Google. Google's super cool. They're like, hey, you want to do a cool project with us? We're going to open source what makes Google Google. We're like, yes. I mean, how do you say no to that, right? But you guys are Red Hat. You're the biggest open source people on the planet. We want to work with you and partner with you. We jumped all over that. I can tell you that. And we're like, let's open source Google. So that's called Kubernetes now. Those origins come from the Borg. Yes, that's what they called it inside Google, the Borg. But basically, they launched 2 billion containers a week with this software. 2 billion. Now, you probably don't need 2 billion. As a matter of fact, I got about 20, but that's pushing it, right? Especially on a laptop with only 16 gigs of RAM. But think about it. You might want to push a few more in those. A Kubernetes cluster has a master and multiple nodes. Think of these as the slaves or workers, right? The master is basically the controller. It has a nice API layer. It is infrastructure as code. It has an API, a RESTful scriptable API. You drive it. You say, launch more of these resources. I'll just show you some quick examples of it. It has the concept of the pod. The pod is a container. Just mentally say pod, container. A pod is specifically a group or family of whales, all right? And the image for Docker is a whale. So that's where the pod idea came from. Replication controller basically ensures that you have multiple replicas of this software, so you have immediate load balancing and immediate high availability. All right, that's what this job is. You want load balancing and high availability. Replication controller says make sure 2 or 3 or 4 of these things are running. Service, okay? Service groups these pods behind a specific virtual IP address. It gives everything an IP address all within the cluster. That's pretty awesome. That means you can run 20 different things on your laptop all on 8080, which is what I'm doing. Okay, because everything has an IP address, even on a laptop. Kind of weird. It's kind of wild. And then, of course, you can key value pair and label all these things. So the pod, of course, is a family of whales. We mentioned that. This is what it looks like when we add OpenShift to it. OpenShift adds additional capabilities to it. Primarily, what you're concerned about is the routing layer, because what happens is, as the request comes in from the outside internet, the routing layer basically receives that, and then, of course, load balances that through the service layer and into the actual pod or container that's going to run that code or run that request, respond to it. And then what's cool about that is if should something die, like let's say that server dies, it'll load balance and replicate those pods someplace else. until that server comes back online, then it'll schedule them back over there again. So Kubernetes is managing the entire state of the cluster for you. You don't even have to think about it, as an example. Okay? Let's just show you a demo, and we'll try to go as fast as we can in demo mode, if that's fair. We have approximately 10 more minutes. Okay, so let's go fast. Okay, all right, what do we got here? Let's see, okay. I have nothing in my node land running right now. Let's do this. Let me see, where am I at? Sometimes I forget where I'm at. Okay, I'm actually inside my Red Hat Enterprise Linux virtual machine right now. Let's go to the node demo. I'm just going to run a quick Node.js Docker build. Let's see if I can remember it. T Burr / my node v1. Let's see if that's the right way to do it. There we go. There's my Docker build. Okay, so I actually just used a Docker file and a little Node.js routine. We can look at what the Docker file looks like. And I built a little Docker container. Okay, you can see it's super simple there. It basically says from, and I'm using this Node.js on Rail base image, and I'm simply adding my little bit of code to it, telling it how to invoke that little bit of code. And if I did everything correctly, I can say Docker run. Let's do a -d -p 8000 because this is on 8000. You can see the 8000 up there above, and Burr my node v1. Let's see if I did that correctly. Okay, so if I did that correctly, come to our browser. We'll go the IP address of that virtual machine that I'm running, 8000. Let's see if we did it. All right, fantastic. It says bonjour there. You guys see that? Okay. Now let's have a little fun with that. We're going to go do a Docker exec dash. Oh wait, we gotta do this first. Docker ps grep my node. Let's see what we got running. Okay, there it is. Docker exec dash it. That guy. Bin bash. Let's see if this will work. All right, we now have shelled into the Docker container. Okay, so we're inside there. I can do a cat etsy system release. See, it's also a Rail container. I can do a PS though. Check that out. I'm actually in a virtual machine which is running a ton of stuff, and now I'm inside the container which thinks it's running just a little bit of stuff. Okay, so I can kind of play with this, and we don't have a lot of time to spend here, but let's just whoops. Let's go back here. Let's just do this. We're just going to kill this guy for now. Docker stop, Docker remove. Okay, and I've now cleaned it all up and I'm ready to go again. So I started the whole web application server, played with it, tested it, killed it. It's that easy or that hard in Docker land. But what's tricky is, what happens if you want to run 3 of these things? Docker run, Docker run, Docker run? You could. You could run 3 Docker runs, just as I did here. But I wouldn't recommend that. Okay? So what we're going to do is, I have a whole series of scripts here. Let's see if they're working okay. Let me try this. Okay, good. All right, so let's do this. I'm just going to run the scripts because it's easier for me. All right, so there's my namespaces. Those are Kubernetes namespaces. These are groupings of, we call them projects or namespaces. It's where you put containers together, okay? Very straightforward. You can decide, okay, this developer has this access to namespaces, this operator has access to those namespaces. It's just a grouping metaphor, okay? Just a grouping mechanism. And I'm gonna go, let's run the number 2. All right, let's create a new namespace. And yeah, we'll just go back up here and query again. So I just added one called Kube Demo. And to kind of make that point, we'll open up the, 8443. I know you can't see me behind the monitor anymore, can you? This is what happens when you're not very tall. Okay, so that's the namespace I just created. I'm just using the OpenShift console. OpenShift sits on top of Kubernetes and complements Kubernetes. We're the 2nd largest contributor to Kubernetes outside of Google itself, so we live in Kubernetes land. Let me see what else I have here. Okay, so I have all these scripts, and I can give you guys these scripts. It's not a problem here. Let's do this. We're going to do a create pod. Look what happens here. kubectl in the namespace kube demo. Okay, run my node version 1. That was the one that said bonjour. And so we're going to fix that in a second. So we're creating the pod. So I'm going to do kubectl get pods, and see there's a bunch of them because I'm running a bunch of other things. Okay, but let's do the namespace. Okay, hold on a second. Let's do this, 5, get pods. So within that namespace, there's my 1 that I'm running. Okay, so I literally just launched that Docker container that fast. It's now running as a server, and I can play with it. But in order to play with it, we need to expose the service. So there's the service exposed, and now I can curl it. Okay, so I'm going to curl it, and I'm hitting that bonjour service now. So, you can sit here and play with it. I'm interacting now with that bonjour service, but we can have some fun here. Okay, that was number 7. You notice I number these things because otherwise I just forget them. But let's do number 8. Let's scale it up. We want 3 replicas. Now we're load balancing and have high availability. I have 3 of these servers running now. Okay, so if I come back and curl them again, okay, I'm going to see, if you notice right here, you're going to see 3 different node names show up. So there's 3 different ones. It's not doing round robin load balancing, it's doing random load balancing by default. That's the default load balancing algorithm in the setup. But you can see it actually picked, these are the node names, these are the server names of that piece of code. This code thinks it's running on a completely different server. It doesn't know that it's living all on this one virtual machine, all within this Kubernetes cluster. So the code you write is not even aware that it's living in a just highly optimized, highly virtualized universe. Okay, so let's do this now. Okay, dun, dun, dun. We're getting a little crazy here. Let's go into the bonjour code. This is just a Node.js endpoint because it's easy. Salut, is that good? Okay, let's see if this works. Okay, we're going to do the same thing we did earlier with the Docker build, but I just have a little script that does the Docker build for me. So it's doing a Docker build and it's setting it to version 2. Okay, so it's doing a V2 version of that build. So we have a version 1, and now we're going to have a version 2. One's bonjour, and one's salut. Okay, and now that it's built, I'm going to then say, and actually let's do this. We're going to roll the update. I think I have another window. Oh yeah, here we go. This is what happens when you have too many windows, somebody get a little lost. Watch the update, roll the update. I closed the wrong window. All right, we're rolling the update. Watch what happens here. Oh, it helps if did I do something wrong? Yeah, I'm keeping rolling update for 35 seconds. Oh, okay. I must have did some, I had a false keystroke in it. All right, so we're rolling the update. You can also see it happening here in our console. And then watch what happens. So basically, we're going to version 2 of that piece of code. But we're rolling the update. And the cool thing is, there's really, oh, do I have bonjour in there? It didn't take my salut change. We can fix that, okay? So why did I go to version 2? And I thought I had a version 2 image, but okay. Can you highlight when you should use Docker Compose and when to use Kubernetes? Question on Docker Compose versus Kubernetes. So Docker, I had this discussion earlier. Didn't we have this discussion earlier? So Docker Compose is a beautiful thing specifically for doing things on your laptop, but it's not a production-ready experience. Docker Compose doesn't give you all the load balancing, high availability, and everything else you need in production. Kubernetes does. So that's really the mental mind shift you have to do in that land. And now I need to figure out why in the world my version 2 did not make it through the system. I'm pretty sure I did that right. All right, but we don't have a lot of time here. Let's see. Okay, there's version 2. And I said roll from 1 to 2, did I not? Yeah, I might have. I edit these files all the time. Let's see. Yeah, so here's what it is. I made the echo version 1, but or version 2. There we go. All right. This is when you're hacking away on stuff. All right, let's try to roll that upgrade again. Okay. Try one more time. So again, the cool thing is you just keep rolling back and forth. It doesn't really matter. Okay. So we're going from the old version to the new version. There it is. All right. You notice too, it's still load balancing across them both. You get a couple bonjours, you get a salut, right? And eventually you get a salut. And if you don't like it, you roll it right back. So now you're thinking in the mode of, oh, blue-green deployment. I can do 2 things simultaneously. If I roll out a bad change, I can roll it right back and go to the good thing. You need this if you want to deploy fast. If you want to deploy multiple times a day, or even every week, you do that in a blue-green style deployment. You do it with this kind of technique. So if you do deploy and it's bad, you roll it back, and now you're back to good again. It's part of the fast deployment cycle. You want to do it safely. But you can see it's going through its process now. We won't wait for it because we've got other things to show you in this little demo before I run out of time. I don't want to take too much time away. And I should make one point before we finish up here. If you guys actually send us a tweet at Burr Sutter at Inaga, a nice picture of our event tonight, we're going to actually have a few t-shirts to give away, like one I'm wearing here. We only have a few, though. So just keep that in mind. So when Edson gets on, he'll talk to you more about that. But let's do this. Let's go over here to the Hystrix monitor. I'm going to show you a couple of these things because this is super awesome. Okay, so we have a service over here. We have a front end that does a lot of interesting, cool things. But what I wanted to show you in particular, okay, is let's go to the service chaining. So if you notice, bonjour here is at the end. This is a different bonjour, by the way, than the other one. Again, you can have as many of these things as you want, different versions, different images. This one's actually, again, a Node.js system, but it's a little bit different. Let me see if my Hystrix console is working nicely. Okay. All right, so let's see if we can make this work. Okay, watch what happens here. Let me make the windows fit properly. You notice the circuit says closed, and everything looks like okay. You can see these nice little green requests, 3 requests green. That means all those good. But let's come over to the main console for OpenShift. Let me find this Bonjour service. It's in a different namespace. That's why it still works, right? I'm going to roll it down from 3 to 1 to 0. I just killed that service. All right, I purposely killed it for the point of the demo. But watch what happens when I hit refresh now. Notice it says fallback here. See that word fallback? That's super critical because our code is still okay. It's just that that service is not responding. If you notice over here, it said 50% were wrong, but the circuit is still closed because we configured Hystrix to basically say until you get 5 bad requests, and watch closely, watch this closed guy here, don't open the circuit until you get 5 bad requests. So let me pound on a little bit more. And now it's open. And if you watch this little blue number now, we're going to short circuit those requests. So what happens is you're bouncing off fast. You're not kicking the dead guy any longer. I know that's a subtle distinction, but it allows your code to be that much more resilient. And if a service is for some reason down, your code who's calling that service is still okay. You're not falling apart also. You don't have a cascading failure through the entire infrastructure. It also deals with services that are slow. I have a demo that shows you what happens if the service is just slow. You can time out and bomb out of that way. Okay, so if we heal the infrastructure, let me refresh the screen here. All right, this thing's getting really slow, as you can tell. And we're going to scale back up to 1. Notice that little yellow box there should go blue when the service is online, because Kubernetes, by the way, has default health checks and readiness checks both in the system. So it's constantly seeing is your service healthy by default. Blue ring means it's ready. I go good there, and watch what happens. Closed. I don't know. It happens so fast you might have missed it. But basically, oh, it's healthy again. We're good. All right, and that's a feature of Hystrix running on top of the Kubernetes backbone to ensure that you're getting that level of circuit breaker, bulkheading, and ensuring your infrastructure is good. I'll show you. Let me show you one other little demo, if we can do it. Yeah, it's very similar to the one you just saw with the Kubernetes one, but I think it's an interesting one to do nonetheless. Let's see. We're going to pull Bonjour there again. Okay, we keep beating. I like beating up on Bonjour for some reason. I don't know why. It has nothing to do with the French word or anything like that. It just has to do with the fact that it's actually a little Node.js thing. I can just hammer, beat it up, and destroy it. So we're hitting Bonjour there, and you can see we're scrolling against it. Okay, let's roll Bonjour back up to 3. Okay, or actually 4. I clicked the button too many times, but it's going up to 4 now. And now my machine is really slow because I just launched 4 additional containers on top of all these others. I'm running, as I said, most of these are JVMs too. I'm running a lot of individual microservices, individual Docker containers on this Kubernetes backbone. But you can see there's Bonjour coming online. And by the way, I have other stuff in here too. We have a full Jenkins environment running here. We can do continuous integration, continuous deployment. We have Vertex, Drop Wizard, and again, all this is available to you at bit.ly MSA instructions. But let's go back over here. So Bonjour is coming online now. And I'll just want to quickly show you the concept of a blue-green deployment. So we're load balancing there. And let's bring up one of these guys here at the bottom. So this works in a similar way to what you saw earlier, but in this case, it's concept of a canary deployment, and hopefully it'll work for us, but the canary deployment is pretty important. The concept of the canary comes from canary in the coal mine. And I don't know if you have coal mines here in Romania, but we have a lot like in Kentucky and parts of the United States. You got coal mines? Gold. So you probably don't have this problem as much in gold category, but in coal mines, coal and natural gas tend to be near each other, okay? And what happens is the coal miner, they tap the natural gas vein by accident, they die. Natural gas doesn't have much of a smell, but you can't breathe it either, okay? So they take a canary in a cage and down in the coal mine, and they're working on digging out coal, and the canary sings, so it provides entertainment. But if the canary falls over, they get the hell out of the coal mine, okay? They run. And you can see the same idea applies here. So my canary is now deployed. It's being load balanced. This allows me to check a whole new version of code to see if it's right or not. And I can just take a subset of user requests and bounce it off my canary. I can even get really clever. Only employees of the company see this new version. Only customers in, Georgia. I guess Georgia's not a state here, right? So Georgia is a country, right? In my case, I'm from Georgia or Alabama, Georgia, Alabama, right? Only customers in Alabama see it, as an example. And so you can have some fun with that and decide, okay, it's good enough for everyone else, and then roll it all the way out or roll it all the way back. With this kind of infrastructure as code, this kind of cool stuff, you can do a lot with your code, and this allows you to deploy quickly, all the time, every day, 10 times a day, 100 times a day, if it's this easy. You can now start practicing continuous integration by making a code change quickly and watching it actually hit production instantly, if necessary, right? And you can then learn from your users in production and then make changes accordingly. And so in this case, if I decide the canary is not good, I don't like the word canary, I can just roll it right back. Okay, scale down. So let's kind of wrap up here from a slideware standpoint. And this demo is very extensive. We could go on and on and on, show you how to do all kinds of things, but there's bit.ly MSA instructions for more information on it. It's on the homepage. But one thing I'd encourage you to think about is you don't have to do microservices to take advantage of all these awesome things. So if you actually read this blog post, if you're familiar with Ruby on Rails, right? David Hannemeyer Hansen, I think we call him DHH, the guy who invented Ruby on Rails. He has his own company now called 37 Signals. They produce a product called Basecamp, right? And he says, we roll to production every week using our agile methodology, agile principles with our code base. It's a monolith. We deploy it every week. And that's as fast as we need to go. He doesn't want to do microservices, as an example. As another example of that, okay, Martin Fowler also talks about the fact that if you're going to go down the microservices path, be aware, there be dragons. Because now you have to think in terms of, well, if A calls B and B falls apart or B goes slow, then A dies too? Oh, well, then I have to bring Hystrix in. Well, do we know how to use Hystrix yet? No, we don't. So you add all this complexity to your architecture, and you may not need that complexity. You might just take advantage of all the blue-green, canary, rolling updates, Docker containers and Kubernetes and all that magic with your existing monolith. Works fine with a monolith too. So just keep that in mind, okay? So we're about done here. I encourage you to read the book, Release It. That's where circuit breakers and bulkheading were documented. And if you have any questions, hit me up on Twitter at Burr Sutter. Also, developers.redhat.com is where you can find more information. Download all this. It's all free. You can download Red Hat Enterprise Linux for free. This is something new we just did. You can download any of the JBoss technologies for free. And then you can also interact with us from the website's perspective. And of course, this demonstration is, of course, for you to have also. Wow. I think it's Edson's turn, but we got to take a break, don't we? And we'll hold questions towards more of the end. I'll let Edson answer all the questions. How about that? Okay, let's take a break. Thank you very much.